Hey, this is Mr. 8 and this is AP Calculus AB. We're going to be doing estimating limits from tables today. So we've been taking a look at this concept of the limit concept. And we had an introduction. We started taking a look at how we find it graphically. Now we're going to be taking a look at what happens if they give us a table of data, a table of a function. You can see right here in this table of data right here, they've given us our x value. Our x value is 3.9, 3.99, 3.999, and you can see we're getting closer and closer to what x value? We're getting closer and closer to the number 4. Now remember, that number 4 might not be defined, okay? There might not be a point at 4. Now you can see we've also come from the right side. We have 4.1, 4.01, 4.001. We're also converging from the right side. So we're converging from the left side as x approaches 4 from the left, and we're also approaching this way as x approaches 4 from the right. So we're taking a look at as we approach 4 from the left and 4 from the right. So let's take a look at our y values, or our g of x values. You can see our g of x values, we have 11.21. Then we have 11.92. Then we have 11.99. You can see what number are we approaching in terms of the y from the left. We're approaching 12, aren't we, from the left. Let's take a look at from the right. We have 12.81, 12.08, 12.01. What number are we approaching from the right-hand side? We're approaching 12 as well. And so you can see how, let's say we have the number 12 right here. And let's say we have the number 4 right here. Okay, so we have 4. And of course, we're going to call this maybe like 3.99, 3.999, 3.9, 3.999, 3.99, 3.9. And you can see as we come from this side, and we are getting this value right here is down at like 11.21, right? And then right here we're at 11.92. Okay, and then 11.99. We're getting closer and closer to this number 12. Now remember, this 12 might not be defined. We don't know. They haven't given us this exact number for 4 in the table. And so as we come from the left-hand side, we're approaching the number 12. We're approaching the value of 12. Now you can see right past this, we have our 12.01, 12.08, and then, and then 12.81, you can see we're much further away, and then we're approaching here. So as we're approaching from this side, we're getting closer and closer. As x is going towards 4, we're getting closer and closer to 12. As we approach 4 from this side, from the right-hand side, we're getting closer and closer to 12. So what is the reasonable estimate for the limit as x approaches 4 of my function? We're getting closer to 12. Because as we approach from the left-hand side and as we approach from the right-hand side, they both agree with one another. They're getting closer and closer to 12. Now, whether g of 4 equals 12, we don't know. Okay, we just don't know. Maybe it doesn't equal 12. Maybe g of 4 equals 14 all the way up here or something like that. Okay. We don't know, but that doesn't mean the limit doesn't exist. The limit does exist, so the limit exists because they agree with one another. The limit exists because it agrees from the left, it agrees from the right, and that limit exists, and that limit is 12. So what are you doing as we take a look at tables? You're taking a look at, does the limit exist from the left-hand side? Does it exist from the right-hand side? And therefore, does that limit exist? And that's estimating limits from tables. Thanks, guys. Catch you later.